Hi, this is the presentation of our final project. So the title of our project is WeMatchSports, and the teammates are me, Onkar, Apte, and Mohit Gupta.
Yeah, hi. Okay, thanks Onkar for the introduction. Now I would like to start with the goals that we have found out. So for WeMatchSports, we have built a simple web application. So the main goal was to help everyone find some sort of a sport buddy that they want to play with. Now some features that we have is, so we can view some sport specific public rooms so that you can get the news about a specific sport. You can get matched with some similar skilled players using our matchmaking microservice. You can even chat with the matched players. And we have also built a responsive, safe, and a user-friendly platform that facilitates real-time communication. We leverage server socket layers to secure the whole of the system. And finally, we have containerized our Django project using Docker and Kubernetes. Yeah.
All right, let's look at the architecture. So we have few clients. They send the request to the REST API gateway, and the request is redirected to some microservices. So we have 4 microservices, and these, form the server. And for messages, we have 2 modules. One is message encryption and message decryption, so that the privacy of the user messages is maintained. We also have a queue which uses Kafka, producer and consumer. And then finally, the microservices retrieve and store their information in the database via a cloud. Let's look at the interactions. So in the front end, we interact with the backend via a gateway. Then we have REST API, which receives and redirects client requests. We have microservices, 4 of them, and they are assigned for specialized tasks. Then we have message queue. We use Kafka here, and these handle the message efficiently without overloading the server. And for database, we use MongoDB, which is a NoSQL database, which stores and retrieves data for use by the microservices. And security layer, as I said, message encryption and decryption, so to protect user privacy.
All right. So as for the software components that we have, so for the front end, we started with HTML, CSS, and JavaScript. For the backend, to store all the data, we used MongoDB. And as I said, we used SSL certificates to keep the system secure. Then we also used Docker for doing the containerization. In the backend, we have used the Django framework. And for the message queuing, we have made use of Kafka. And microservices, actually, they are trying to communicate with themselves using REST APIs. And finally, we have done some sort of monitoring and logging using Python libraries. And as for the hardware components, we have cloud servers. So our MongoDB is stored on a cloud. So it's a cloud database. And the second part of the hardware component would be the like smartphones, tablets, or the computers via which we can access the WeMatchSports platform.
Okay, let's look at the debugging part. So we have 3 parts: code-based debugging, RESTful API debugging, and database debugging. So when we say about code-based debugging, we essentially say about the front end. So in the front end, we use Chrome dev tools or browser developer tools. Essentially, we use JavaScript in the front end for asynchronous requests to the server. So browser developer tools can be used to inspect data coming from the APIs. So for that, we use console.log. We use the debug UI components in the inspect tab. We also monitor the network resources, etc. In the RESTful API debugging, we simulate the requests, check response times, and debug API endpoints. So we have numerous APIs, and once if we use an API and if we land at a link which is not represented by any API, then we simply go to a page with an error message, page not found. Then comes database debugging, another important part, because we have to look at our database and ensure that the data is stored correctly. So for that, we use various visual tools to inspect, query, and validate data in MongoDB. As I said, to ensure that the passwords are hashed, messages are encrypted, it's important to debug the database. So we also use or leverage MongoDB's query analyzer. We query the individual collections and look at whether each collection stores data efficiently and in the right format.
All right. So as for the testing purpose, so we have 3 sort of testings that we have done. I'll start with unit test first. So unit tests have been used for various views that we have in the backend of the Django. So some of the views such as matchmaking view, so that uses a cosine similarity algorithm. And to test that, we have made some sort of functions for it. And similarly for the login, for sign up, and various other microservices, we have some functions for them. Integration testing, I would like to say that we have used Postman to test all the endpoints that we have with the specific data. And finally, end testing, we have leveraged a tool known as Selenium. So like we have tried to simulate a user's interaction from login to finding a match and then even trying to talk with their match players. So we have tried it for about 50 or 100 users, and the WeMatch platform was fine. It worked well.
Let's have a look at the demo.
All right, let's start with the demo then, which is authentication. So we have containerized all the microservices into one particular Docker container. So let us build that first. Let's give it some time, and we can see that we do not have any sort of containers right now, but we do have a image created. So let's go to the container, and we can see that we do not have any sort of containers. Let us run this particular image at port 8000, and the image ID is particularly this. Let us run this. All right, so we see that the Docker container has been built, and let's go to this particular link. And let us start with the sign up first. So email ID, let's say it is test7@gmail.com. The past second game choice would be cricket. Let's say it's football, and let's just sign up. Now we have been redirected to login. Let us log in. test7@gmail.com. The password was 12356 @123. Let us try something else. So this is a wrong password clearly, and let's log in. So we see that we like something is wrong. Let's go back to login. Let's try that again. test7@gmail.com. Let's log in. And here we have the dashboard for Michael Steve. Now that we are logged in as Michael Steve, we can see all of his data like mail, age, favorite games, and all of this data is coming directly from the MongoDB database that we have. Let's have a look at it. This is the MongoDB, and let's directly head to test7@gmail.com. So we see that the password is also hashed. So, and let's head back to the dashboard. So we see a profile icon here, and we can go to edit profile section. We can change some sort of things, like let us change his age to 25 maybe, and let us update the profile. Let us head back to the dashboard. Let us go to the database and verify. So we can see that his age has been changed to 25. So it's Michael Steve Boulder and 25. Yeah. Now in the profile section, we have one more thing, which is public rooms. So if we go to public rooms, we see that there are many specific rooms specifically for one particular sport, like football, soccer, tennis, cricket, basketball. And we see that this particular player likes to play basketball. So if he clicks view, we can see some top 10 news about the basketball sport. So we leverage a news API for this and get top 10 headlines. And if we click on any one of them, we can be redirected to that particular news and we can check it out. Now we can head back to the public rooms and we can head back to the dashboard. And one of the main things of WeMatchSports platform is to find similar players. So this is the matchmaking. So let's click on find similar players. Now what this does is basically it shows the similar matched players that it has. So it uses cosine similarity in the backend. The similarity is based on the age, the city, and the sports that they have. And we can send some connections here. So I've sent it to Michael Jordan, I've sent it to Lionel Messi.
Messaging microservice is responsible for message marshalling, message queuing, and storing the messages back into the database. So for message encryption and decryption, we are encrypting the message using a secret key stored in the main project directory. For message queuing, we use Kafka, and for that we have two scripts, consumer.py and producer.py. So the name of a topic is determined by the prefix, which is a literal, and the ID of the user. So let's run the containers for Kafka and Zookeeper. But now let's look at the Docker desktop, and we see that the two containers are successfully running. So given that our application container is running, let's look at the chat functionality. So let's find similar players. Let's send connections to some of them. And I've already sent connections to many of these. So for example, here's a player named Michael Jordan, and we have already sent a connection request. So if we go to that account, we'll have a notification that we have one new connection request. And we can accept the connection request again. We click on find similar players and accept connection request from Michael Steve. Once a connection is accepted, we can chat with that connection. So in this display here, the messages are decrypted and then displayed. So let's type something. Let's type hello and send. So this message was at 7:08 p.m. Let's now look at the database. Let me refresh the collection. And we successfully see that the last message was received at 7:08 p.m. So this is the encrypted form, and this here is the decrypted form. So we can chat with any number of connections once we are connected. And if we have any pending connection requests, we can simply hover over this icon.